It is said that focus on the solution, not on the problem. Very much not possible in mathematics. So today we will learn about the different type of solutions according to the question given to you, according to the problem given to you. So in this video, we will cover exercise 3.2, linear equations in two variables. So be ready with your graph paper, subscribe and hit the bell icon. All right, types of solutions is already discussed in first video, but still a quick recap. Now, if I write a general equation as a1x b1y plus c1 equals to 0 and a2x plus b2y plus c2 is equals to 0, right? So, these are two linear equations given to you. When you will plot them on the graph, there are three possible options which we have already discussed. Like either there will be intersecting lines, right, or there will be parallel lines, or there will be coincident lines. That means one over the other. I'm just showing it to see the difference. Otherwise, they're completely overlapping. So these are the three possible outcomes on the graph. So there are three possible solutions. Like when there is only one point of intersection, lines can intersect only at one point, right? So this will have a unique solution, right? And when they are parallel, of course, they have no point in common, so there will be no solution, right? And when they are overlapping each other, there are infinite points which are common to both the lines, so there are infinite solutions. But now, how do we guess it? Only by looking at or by doing something with the equations rather than drawing the graph. So if you want the unique solution, what the given pair of linear equations should have: a1 upon a2 not equals to b1 upon b2. Their slants should be different, right? So a1 by a2 and b1 by b2 should not be equal. So they will definitely intersect somewhere. When there is no solution, it is a1 by a2 is equals to b1 by b2 but is not equals to c1 by c2. That means their slants are equal but there is a distance between them. So there will be parallel lines. Infinite have everything equal. That is why they overlap, right? a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. And you have to learn these three conditions because there are small 2 markers, find the value of k or find the value of p based on these. And since there are more 1 markers this time, MCQs, so these are very commonly used for those questions. So you have to compare the coefficients a1 upon a2, b1 upon b2, c1 upon c2. Here you have to be careful that c1 and c2 either are both on LHS or both on RHS. You can have it here, but then both of them should be on LHS or both of them should be on the RHS. All right, so let's start with the exercise. So exercise 3.2, question number 1, first part. 10 students took part in mathematics quiz. If the number of girls is 4 more than number of boys, find the number of boys and girls who took part in the quiz, right? So we don't know how many boys and how many girls, right? So I'll say let the number of boys be x, right? The number of boys be x and the number of girls be y. And the number of girls be y. So 10 students took part. So first thing that we know is that x plus y is 10. And number of girls is 4 more than number of boys. So number of girls is 4 more than boy. Please move it with the according to whatever is given in the statement. It will help you form the equation better. So this is your first equation. And what is your second equation now? If I transform everything to the other side, it will be x minus y is equals to minus 4. So this is the second one. Now I'll have to plot it on the graph. So let's find some points, right? X plus y is equals to 10. I'm plotting it here. The points, only the points I'm talking about. So x and y. So this is easy. You can do this orally also. So x 5 and 5, right? 6 and 4 and 7 and 3. General, because the sum is adding up to 10. And then the other one, always take 3 points. Right? So I'm taking, it is x and y. Two values can do, but take 3 for more perfection. All right. So if I put x is equals to 0 in this case, I get y is equals to 4. And if I put x is equals to, or I may write it like this also here, that y is equals to x plus 4, right, for this one. So if I put x equals to minus 2, I get 2 here. And if I put equals to minus 1, I get 3 here. So I've got 3 points. Now let's draw the graph. Let's plot the points. So first I'm doing this one. X is 5, y is 5. So if x is 5 and even y is 5, this is the exact point here. And then x is 6 and y is 4. So this is the exact point there. Then x is 7 and y is 3. Now these points can differ, right? You can choose some other points as well. And if I draw it now, if I join these lines, right, I get them exactly this way here. And I can name it, always name it, right? And you get it as x plus y is equals to 10. Right, let's plot the other one. X is 0 and y is 4. Okay, so this is the point here. Then x is minus 2, then this is 1 is 2 here, this point here. And then if x is minus 1, it is 3 here. This is what we get here. And if I join it, if I join the line, this will be something of this thing here, right? So I'll have to extend this one also a little like this. And this is the point of intersection. I'll have to measure what point is this. This is 6 and this is 7, right? So this is 7 here. And if we put it down there, this is 3, right? So your solution is x is equals to 3 and y is equals to 7. Now see what did you decide for x and y? X was the boys. So there are 3 boys and there are 7 girls, and that's your answer. Okay, second part now of this question. 5 pencils and 7 pens together cost rupees 50. So I'll say cost of one pencil be x and cost of one pen be y, right? Now conditions, 5 pencils, that means 5x plus 7 pens, 7y, cost rupees 50. We are done. First equation is done, made. And 7 pencils and 5. So 7x plus 5y, that is equals to 46. So we have to solve it graphically. So we will find the points. So for the first one, 5x plus 7y is equals to 50, right? I may write it as 7y is equals to 50 minus 5x, right? Or y is equals to 50 minus 5x upon 7, right? So let's find the points. All right, if I put x is equals to 10, I get y is equals to 0. And if I put x equals to 3, I get y is equals to 5, right? So otherwise I'll get into decimals if I take any more. Then let me find for this one now. So it will be y is equals to 46 minus 7x upon 5. Okay. Okay, if I put x equals to 3, so it's 21 and 46, 25, so it will be 5 here. Just looking for a whole number, easy to plot actually. And then if I put x is equals to 8, right? If I put x equals to 8, 2, rather minus 2. Okay, so let's plot the graph. Okay, the coordinates are ready, so let's plot the point now. X is 10, y is 0, so it is exactly at 10 here, and this is the point. You write it as 10 and 0. Then x is 3 and y is 5, right? So this is exactly here, this point here. So we will join them. All right, this is where it is joined, and I'm naming it as 7x plus 5y is equals to 46. Now the other one is x is 3, y is 5. That's the same point there, right? And x is 8 and y is minus 2. So if x is 8 and y is minus 2, this is somewhere here. Okay, and now I'll join them. Okay, and I will name this one as, if I extend it further, this one is 5x plus 7y is equals to 50. So we found a point of intersection at 3, 5. So your answer is x is equals to 3 and y is equals to 5. What were the x? X was pencil, right? So pencil is for rupees 3 and pen is for rupees 5. Exercise 3.2, question 2, first part. Now, on comparing the ratios, find out whether the lines representing the following pair of linear equations intersect or parallel or coincident. I told you there are only 3 options available. Now, first let's find out what is A1, A2, right? So, what is A1 here? 5. What is B1 here? Minus 4. What is C1 here? 8, right? Then what is A2 here? 7. What is B2 here? 6. And what is C2 here? Minus 9. Always see constants should be on the same side, either RHS or LHS, but they should both be on the same pattern. Now let's find out A1 upon A2. A1 upon A2 is 5 upon minus 4. Then B1 upon B2 will be minus 4 by 6, and I reduce it, I'll get minus 2 by 3. There's no point to go to C1, C2 now, we're already done. C1 by C2 is 8 by minus 9. Now here clearly you can see that A1 by A2 is not equals to B1 by B2. Now this is a condition for unique solution, right? Or that means the lines will intersect at a point. They will intersect at a point, right? Let's move to the second part now. If you look at the second part, again, first let's find out what is A1. A1 is 9, right? B1 is 3 and C1 is 12. Then A2 is 18, B2 is 6 and C2 is 24. So A1 upon A2, that is 9 by 18, can be reduced to 1 by 2. Then B1 by B2, which is 3 by 6, is also 1 by 2. Then C1 by C2, which is 12 by 24, is also 1 by 2. So in this case, A1 by A2 is equals to B1 by B2 is equals to C1 by C2. All three are equal. So this means the lines are actually coincident. Coincident, right? It is basically the same lines only, right? So coincident lines, right? They will overlap each other, or if they ask for solutions, such a case will have infinite many solutions, right? Let's look at the third part now. 6x plus 3y plus 10. So A1 here is 6, B1 here is minus 3, and C1 here is 10. Then A2 here is 2, B2 here is minus 1, and C2 here is 9. All the ones from the first equation, all the 2's from the second equation. Now let's take the ratios. A1 by A2, that is 6 by 2, that is 3. Then B1 by B2, right, which is minus 3 by minus 1, which is plus 3 again. Then C1 by C2, which is 10 by 9. So what are we concluding here? That A1 by A2 is equals to B1 by B2. Their slants are equal, but the distance from the origin is not equal. That means these are parallel lines. These are parallel lines. And if you look for the solution, there will be no solution, right? Because there is no point which is common to both of them. So there will be no solution in this case. Now, question number 2, again, we have to compare the ratios. And this time we have to tell whether the pair given to you is consistent or inconsistent. Now, consistent means there is a solution, whether it is unique or there is infinite solutions, but there is a solution. Inconsistent means that there is no solution, right? So out of 3, 2 cases fall in consistence and no solution is inconsistent. So similarly, looking at the first equation, we will have A1 as 3, B1 as 2 and C1 as 5. Then A2 as 2, B2 as -3 and C2 as 7. Again, C1 and C2 both are towards the other side of the equality sign, right? They should be on the same side. Now, A1 upon A2 will be 3 by 2. Then B1 by B2 will be 2 by -3. We can see a very much difference here only. Then C1 by C2 is 5 by 7. So A1 upon A2 is not equals to B1 upon B2. When the first two are not equal, it's okay, we're not concerned about the third one. So here, yes, there is a solution. There is a unique solution possible, right? And thus we can say they are consistent. Consistent. All right, let's do the second part now. For the second part now, again, C's are on the same side only. So A1 is 2, B1 is -3 and C1 is 8. Again, A2 is 4, B2 is -6 and C2 is 9, right? So let's take the ratios now. A1 upon A2 will be 2 by 4, that is 1 by 2. Then B1 by B2 will be -3 by -6, again 1 by 2. And C1 by C2 is 8 by 9. So we can easily see that A1 by A2 is equals to B1 by B2, but it is not equals to C1 by C2. That means this is a case of parallel lines. And parallel lines, they have no point in common, so they have no solution. So the answer is no solution. And if we want to answer in the term that they wanted, consistent or inconsistent, we would say inconsistent, right? Let's go to the third part now. Moving on to the third part. Now, what is A1 here? A1 is 3 by 2. What is B1 here? 5 by 3. What is C1 here? 7. Similarly, what is A2 here? 9. What is B2 here? -10. What is C2 here? 14. Right? So, let's take the ratios. So, A1 upon A2. Right? So, it is 3 by 2 and 9. So 3 3s are, I get it as 1 by 6. Then B1 by B2, that is 5 by 3 and -10, right? So I get -1 by 6. So be careful, even if there's a small sign change, they are unequal only. And then C1 by C2, we need not even go there because we've already found the first two incomplete, by 14, right? So there's no point finding this ratio also, right? So now A1 upon A2 is not equals to B1 upon B2. That means there is unique solution. And unique solution means the given equations are consistent. All right, let's move to the next one, fourth part now. Now fourth part, A1 is 5, B1 is -3 and C1 is 11. Similarly, A2 is minus 10, B2 is 6, and C2 is minus 22. Let's take the ratios. A1 by A2 is 5 by minus 10, which is minus 1 by 2. Then B1 by B2 is equals to minus 3 by 6, which is again minus 1 by 2. And then C1 by C2 is 11 by minus 22, which is again minus 1 by 2. So all the three ratios are equal here. So A1 by A2 is equals to B1 by B2 is equals to C1 by C2. That means they are coincident lines, that is overlapping lines. And how many solutions do they have? They have infinite solutions, right? They have infinite solutions, and hence you can say they are consistent. Yes, solution has to be there, whether unique or infinite, solution should be there. Moving on to the fifth part now. Again, what is A1 here? 4 by 3. What is B1 here? 2. What is C1 here? 8. Again, what is A2 here? 2. What is B2 here? 3. And what is C2 here? 12. Let's find the ratios. A1 by A2, that is 4 by 3 and 2. You get 2 by 3. Then B1 by B2, that is 2 by 3. Simple. Then C1 by C2 is 8 by 12. That is again 2 by 3. 4 2s are 4 3s are. So again A1 by A2 is equals to B1 by B2 is equals to C1 by C2. All the three are equal. That means they are the coincident lines. Coincident lines have infinite solutions, and there is the solution, whether it is unique or it is infinite. Hence we can say they are consistent, right?